Hello guys, and welcome to today's daily Leetcode challenge. Today we'll be solving question 1716, calculate money in Leetcode bank. Let's get straight to the question. Hersey wants to save money for his new first car. He puts money in a Leetcode bank every single day. He starts putting $1 on Monday, the first day. Every day from Tuesday to Sunday, he will put one more than the day before. So if I was to draw this out, the week starts with $1, and then it goes 2, 3, 4, 5, 6, 7, 8, right? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Oops, 7. Let's see then what happens. On every subsequent Monday, he will put one more than the previous Monday. So this is week 1. What does week 2 look like? Well, week 2 doesn't continue from 8, right? It starts from 2 and goes up to 3, 4, 5, 6, 7, and 8. So this is week 2. You can see the pattern here. There are little spikes of, there's increases in the amount that he puts down throughout the week, but it resets to a smaller amount each subsequent week. And the question here says that if given that n, which is just the number of days, return the total amount of money he will have in Leetcode bank at the end of the nth day. So we're not given a specific week. We're not given this term in weeks. We're given it in days, meaning that the investment time period can end maybe the 4th day or the 5th day of the second week, and we would have to take into account the whole previous week and a portion of the second week. All right, well, to kind of start thinking about this, it's important to recognize what the sequence here looks like. And what it really is an arithmetic progression. These arithmetic progressions are very common in Leetcode questions. You see them pretty much, well, not everywhere, but commonly. You would see something like, what is an example of a arithmetic? Well, I mean, just 1, 2, 3, 4, 5, 6, and so on until like until some nth day. And a very common way to write out a geometric progression, the formula is this, plus xn, where you have 2s is equal to x1 plus xn times n number of times. And so you would get something like the sequence is equal to the sum of this times n. So you would call that, I don't know, x sum times n over 2. It's commonly written like this also, n minus 1 n over 2. You might have seen this before. Here, we're given a little bit of a different scenario. We don't start from 1 each time. Let's write out what the arithmetic progression for a week would look like. Well, we would have an x. We would have an x start. Oh, let me write this out in blue. X start, and then on the first week it would just be 1. Then we would have x something else, x this, x this, x this, and these are all additions until we get to xn or xf, let me call this xf, which is the final day of the week. In this case, it's going to be 7. So what if I wanted to figure out what the arithmetic progression or this arithmetic sum for a week is? I would say that the sum is equal to this, but then I want to say 2s is equal to, say, xs plus xf times actually xf minus xf minus xs, because xf minus xx is the amount of times that x appears here. Plus 1 actually, because if this is 7, 6, it appears 7 times. And then we would say that s is equal to just xs plus xf. I'll just say this over 2. So there we go. That is our sum for a week. Let me code this up real quick and see if that's actually correct. Def week sum, and I want some parameters in here. I want to xs, which is just the start, and then I want the number of days in the week that we have. There are always going to be 7 days, so what is going to be xf that we want? Xf is just xs plus days minus 1. What is this? Why is xf just xs plus days minus 1? Well, 1 plus 7 minus 1, which is the first day, plus 7, the 7 days, minus 1 gives us 7. So 1 and 7. Xs is 1, xf is 7. And now we just need to return this formula that we have devised here. This is going to be xs plus xf times the number of times that this value occurs, which is just going to be xf minus xs plus 1, I believe, right? And all of this divided by 2. Let's check if this is correct by running the first week through it. Print 1, and we have 7 days. And if we have 1 and 7 days, then that is the equivalent of this, which gives us 28. Let's see if 28 gets printed when we have 1 and 7. 1 and 7, oops. 28, we're looking for 28, perfect. And what if only 4 days are included? First day, then we should get a total of 10. Awesome. So there we go. We have just computed basically what it's going to take to how much value accumulates in either a week or some number of days, given that we have the starting day. So now all that's left is we have the full weeks, the count of full weeks, and that is just the n divided by 7, and the left over days is just going to be n modulo 7. Now for, let's say, week in range full weeks, I'm going to say that I need this value here. S is equal to, this is my return value. It's going to be ret plus equals week, starting with week 0 but plus 1, and always 7 because we're completing the week here. And then finally we need to do this one more time, except the week is going to be the full weeks plus 1, I believe, right, because it's the week that didn't get captured fully. And the number of days is this. And that's it. We can return ret. Yeah, this is an easy level question. I'm sure that there was probably a less math intensive solution, but this one is very clear and intuitive, and so decided to use it. Yep, definitely not the fastest. Let's look at what these guys are proposing. These guys are proposing that we have a count, which is just the amount of money accumulated. The number of weeks is just going to be if the week is not full, if n isn't fully divisible by 7, then it's going to show an extra week. If it is, however, it's going to show an extra week. And then for week and range of weeks, if week is equal to week minus 1, weeks minus 1, this is, so I see what they're doing here. They're going through and iterating through all the possible, all the days that actually accumulate. But how is that faster? How is that faster? Because we're doing it mathematically. They're doing it through an iteration. They're saying that for all the full weeks that there are, which they're claiming is in weeks, it's going to be week, go through 1 to n modulo 7 plus 1. Yeah, there's just no way that this is faster, because and it's harder to read. Oof. My solution here avoids having to do any loops that aren't necessary. So I don't understand why. Let me try rearranging something in hopes of making this simpler. Let's remove this. Leftover days, we don't need that. It's just n modulo 7. I should be getting a faster solution because there are less iterations that I'm doing, but it just doesn't want to do it. I don't know. I like my solution. If you understand this fully, I suggest you use it. It's probably more pretty, I would say. The others are definitely easier, and they somehow get away with it being faster, but I don't understand why. Cool. I guess with that, let's end today's video. Thanks for watching. Please like and subscribe. Catch you later.